Sometimes when I'm building a quad, I just have to kind of go a few days, sometimes minutes, sometimes hours, sometimes days, just thinking about what I want to do. And this guy has been taking me a few months now. Not its fault. I've had some life things happen, but just let's go over a few of them. So one hindrance to my immediate ability to finish things is I don't know how to make very much in 3D design. So I'm kind of at the the mercy of what's out there on Thingiverse or Bamboo Labs Maker, whatever it's called. And I had this design from Falcon Rad because I'm getting that hopefully in the mail today. I don't know when I'll get it. It's coming from Canada. But I'm getting the new 7.5 inch Falcon Rad RPM. And this is a hacked up TPU mount that I printed and just made it work with this 04 Pro. You can see so normally it has a 915 megahertz holder out here in the front. So I cut that off with it's kind of like a soldering iron with an X-Acto blade on it. My wife has it for some of her art stuff, but it works really well for cutting TPU. So I can print kind of what I want and then chop stuff off. Or in this case, make it fit the 30 millimeter post spacing by just kind of splitting it down the middle and then chopping some out of the back of it so that it'll fit. Because this is made for an 04 Pro. Because I actually asked Falcon Rad if he could make one of those for me, and he did for his, but I'm just going to reuse it and hack it for this. I can print another one when that comes in. Not real happy with just using tape to hold the 04 video cable, camera cable down, but for now that'll work. I also don't like all this rat's nest in here. I'm not sure how I want to fix that. Might not fix it. If it works, don't fix it, right? These antennas are for this guy, which is a Radiomaster Gemini receiver, and I couldn't get it to work on this receiver port that I made a connector for. So I'm going to try to reuse it because this one does work. This it's not the port that's not working, by the way. This bound and worked at first, then I upgraded it, and now it won't bind to my transmitter, like no matter what. Even though everything says it should bind, it waits and flashes like it's in bootloader mode until it's 30 seconds, I believe, and then it goes into Wi-Fi mode. And I can log into the Wi-Fi page, I can re-upload code, reboot it, blah blah blah, but for whatever reason it is not wanting to play with my transmitter. So I stuck a EP1 on here, which is not going to use these 900 megahertz antennas, but it is a dual antenna receiver. So I plugged it in there. It's 2.4 gig only, but whatever. But it's kind of short. I don't know. I would just reuse the silicone wires that were on it. Don't really like those, so I'm going to just reuse this cable with silicone wires and mount it back here wherever it fits properly. So the thing with long-range drones is you really want to keep a few things in mind. Like if you're going to go send this like more than you can walk to get it, which is what I consider long range, I would not just hurry up and go try to fly it. I've done that, and I actually lost this for a while because of that. I flew long range off of a highway and got confused about where I was, didn't have a GPS on it. There actually was a physical GPS chip on this, but my buddies were like, let's go. And so I'm like, okay. And on the way back from flying, one of them's like, you should fly it over there. And I did, and didn't have any idea how to get it back, because you can really lose your orientation when you're way far away from where you are. There's just some of those lessons you just have to learn yourself. And so I sent it. Luckily, I had stuck an Apple AirTag back here. And a week later, it got a ping. Somebody drove by it with an iPhone, and it said, hey, I'm over here. And so I just picked up, as soon as I saw it, I was like, boom, out the door. I was at home, and none of my buddies were available, but I just went and did some direction finding with the AirTag software or whatever. Found it. Awesome. Picked it up. Not too worse for wear. One of the arms was broke and had lost the motor, which is why I have a T-Motor Velox on here, and I have an Axis Flying original motor here and here. And I ended up just saying, you know what, I'm going to put 2 of these T-Motors on, thinking I would just slowly replace all 4. And now I don't know if T-Hobby can actually ship here or not. I'm not going to buy them. I did plug this in and tried them, and all 4 of them do work. So this should fly. And then this is also the one that Gringo and Mrs. Gringo cracked up and apparently watch when they need a good laugh, which I'm totally happy to provide laughs. That's part of this hobby, is you just got to laugh at stuff, right? But I was hovering it in my basement with 11-inch, 11-inch blades on, tri-blades, and flew great. I mean, hovered fine, no problem. And then as soon as I landed on my basement floor, which is kind of a soft, it's that Harbor Freight, like foamy gym floor material that kind of connects together with other pieces, interconnects, and it landed. And as soon as it landed, the ESC decided to catch fire. And wherever I upload this, maybe I'll put a link to that in there. But after that, I started reading on some of the ESC flight controllers specs. That's what's kind of cool about this vlog stuff, I guess, is you can talk more about long form, some of the things that you keep in mind that other people might be trying to figure out. And maybe they don't want to learn it the hard way. They want to learn it through my hard ways. And so one of those is I'd bought a TBS Lucid stack for 6S. They have an 8S version, but I bought the 6S stack because TBS actually makes some pretty high quality stuff. And I start reading it, and it says it's not for quads over 7 inches. And I was like, oh, okay. So I went looking around, and this Sequire, whatever you used to call it, stack is for 8S, and it can handle max of like over 100 amps, like massive, like maybe even 200 amps. I don't remember. It's a lot. It was enough where I'm like, this can handle it. So I purchased this, put it in. It's got really nice castellated pads for the ESC, so you can get a lot of power out to your motors. The original one, I had some race wire that I had made through PCBWay, and I don't think it was allowing enough power to go through them. Possible, but so on this one, I'm just putting straight wire, no race wire, and just really trying to give this guy every opportunity to succeed. And let's see, I did find this TPU mount that I could print for an SMA connector on the back, and it's a kind of a low profile, which is what I like. And then I always like to have two antennas on long range that are as much 90-degree separation as I can get, whether that's like this way and this way, 45 to each other. And in this case, I'm doing almost straight out the back. And if you think about it, when you fly along, you're flying at an angle of some sort. So you're not flying straight out the back. It's actually more up in the air. But the problem with that is as you turn and it comes back towards you, if you have a big battery right here, you're going to miss out on this video signal and you're going to lose it. And I've seen that happen on my quads before. It's not fun. You can then kind of yaw and see and get your video back. But you know, when you start losing video, it's easy to get into a brain panic or brain fog situation, kind of like I was for the last month and a half with my issue with getting rear-ended and concussions and all kinds of that fun stuff. But so what I'm gonna do is I'm gonna put one like you see it, and then I drilled a hole in the carbon plate, top plate, and this will let me have, see that? Now I'm gonna have one sticking way up above the battery and then one back here, and that should give me really solid video signal for the whole time that I'm flying, even if I fly really far away. So I'm kind of looking forward to that. And you'll notice I did the same thing with the 45 and 45 to give me 90-degree separation on my ELRS antennas. And it's, like I said, it's only using these small 2.4 gigs. But what that does is it gives me one side of the quad going this way and the other side of the quad going that way. And these are dipole antennas, meaning one side is ground and one side has the power. And so the way antennas work is you kind of need a ground for the power to push off of, is the way I kind of see it. It's like a springboard that the power needs to be able to push away. And then the other way you can imagine it is, at least that I imagine that might help some of y'all, is when you're talking about RF energy, you'd have to pay attention to a few things for power. One is like, why is this shorter than this one? It's because 915 megahertz versus 2.4 gigahertz is a big difference in the wavelength. And that's literally what you're talking about, the length of the wave. And so a 2.4 gigahertz means there's 2.4 billion up and down, they're called sine waves. So a sine wave, if you looked at it on an oscilloscope, it's where it shows you the rise, meaning positive voltage, going back down to zero, and then the negative voltage, which is kind of like the tide, right? The tide goes positive into the beach, and it goes negative back out to the ocean. That is how you get waves, and that's how you get riptides. That's how you get the tide. You have it coming in, you have it going out. And so by doing these dipoles like this, you end up with only actually transmitting, and you do transmit on your receiver just literally off of one of these wires, not both. And then, but you can receive on both of them. So you're transmitting on the wire that's in the center of the coax. And that's the other place where you can really lose a lot of power, is the coax wire. See the coax wire that's going right there to the antenna. So the coax, the bigger the conductor, the less loss, and the higher the frequency, the more loss you have. So you really need bigger conductors at the higher frequencies. And these are running at 5.8, 5.2 gigahertz, I think 5.8. And then every time you have a connector, you lose half a dB to the connection point. So, every time you don't want to use like multiple connectors in line, because all that's going to do is take away from the amount of signal that's coming from your VTX, whether it's 04 analog or whatever, and going out to here. And literally you want the shortest possible length, because the further you're pushing it, there's literally a specification for each size of coax that has the dB loss per foot. And so you just want to make things as short as possible, and you want to use as big of conductors as possible. It's kind of like batteries, right? You can actually end up melting your solder if you pull more amps than your conductor, your red and black wires are rated for. If you try to put tiny whoop battery leads on here and then plug in this massive battery like this, you are going to be in a world of pain, because you're not going to be able to get enough power, and then it's probably going to smoke the wire to where it literally melts the wire, the copper in the wire. So, I'm gonna probably add, I use these, and I always use silicone wire. I used to have some of these that were wire kits to make your own connectors that were PVC coated, and when you try to solder them, the PVC just melts. It has such a low melting point that it just starts melting away, and you end up with too much wire exposed. And if you end up with a red and a black wire next to each other and they touch, it's going to fry your receiver, and then you're going to fail safe. And then hopefully you have GPS that takes over and flies it back home for you and lands it, because you're going to lose control. Okay, so just trying to throw out as many tips as I can think of that I'm seeing as I'm building this. So my next thing to do is I'm going to put these connectors, I'm going to cut these silver plugs that go in the SHJTX or whatever those little plugins are called. I'm going to cut these off, and then I'm going to solder them onto the ELRS receiver. And eventually I will work on this original Gemini receiver, but I'll probably just put it onto a Speedy B that I have here and troubleshoot it completely separate from a real drone until I can figure out what's going on with it. And so that'll be my next step. And then I'll probably use some alien tape, which is kind of thick, spongy, and super sticky tape. That's really great. And I'll put that back here and tape this receiver down in the back. So this is a receiver, but it sends you telemetry. And so one of the things that's come in handy for long range for me as well is GPS. So if you have GPS on your OSD and all of a sudden your quad goes down somewhere, it's very disorienting or disorientating. I don't know. Let me know, all you English majors, which one is right. But when it goes down and you lose video, at least you can replay your video in your goggles and see the last GPS location that's in there. That's part of the telemetry. If you're recording on your receiver, you want a global variable in here that says start logging data when you arm. That way you can always pull your SD card off, and it's recording all of the telemetry in your GPS when you do discovered telemetry, because you are doing discovered telemetry, right? When you turn on your receiver, bind it to there, and it starts sending you all the telemetry, you need to go into your Radio Master and the model set up to telemetry, and there's a select receive new telemetry or something, and it will start populating all of the telemetry that's being sent from your receiver out your antenna back to you. So that's why sometimes you'll hear telemetry lost on your transmitter, because there's not anywhere near as much power being used on this tiny little receiver to transmit the telemetry back to you as there is from your transmitter out to your receiver. It's usually multiple times. Now they do make some receivers that are made for higher output telemetry. And if you see that, now you know why that is. So after I do that, then I found this really cool arm mounted GPS holder for the HGLRC M100. Now I kind of have a mixed feel for HGLRC. They've screwed me over before on, I purchased a brand new quad and the GPS was bad and they just refused to fix it. I showed them all the data, all the videos, and they're like, I don't care. They didn't even say I don't care, they just quit talking to me. So I didn't really like that. But I do like the fact that, I mean, I had one, so you're gonna use what you have, right? But this GPS is made to fit out on an arm at the end of an arm, or anywhere there's an arm, but there's less stuff for me to worry about. There we go. So see how that just mounts on there? And it's below the props, but it's away from all this electronic noise that's being created. And if you do long range, you want to make sure your GPS is away from the noise. So the best part of your drone for it to be on in the main body is generally like, I think the Turn, the HGLRC Turn, some of the others, they'll have a 3D printed like riser off the front up above the camera that just sits up here and puts the GPS there. Now, the typical place people will see them is in the back, right back here. The only problem with that is, you know, you're right by your video VTX transmitter, you're by your ELRS transmitter, and I am kind of close to this transmitter, so I might end up actually putting it over here. I haven't decided yet. This would actually be the best place for it, is up on this front arm, because now it's way away from all the noise creating things. And you don't want, this is a very sensitive receiver because it's trying to receive microvolts of voltage. Remember me talking about that sine wave as voltage? That's what it is. It's just voltage in the air. And the GPS satellites are pretty far away. And so by the time that signal gets through the atmosphere and all the clouds and everything, the water vapor, everything in the air, down to this tiny little ceramic antenna, I mean, that's like maybe 3/4 of an inch or probably bigger than half an inch, like 3/4 of an inch by 3/4 of an inch. That's not much. And so it's got to recover that and then turn it into a coordinates. And that's going to need as much isolation from electricity. That I'll imagine the power of all of these antennas. They're pumping out, 200 milliwatts, 400 milliwatts. If you have an analog on there, 1, 2, 3, 4, 5, 10 watts of power. And unlike audio, where you run like 1,000-watt speakers into your woofers or whatever, this is a lot different than that kind of watts. It's the same type of watts, but you're going from, just think you're going from these tiny little inputs of your sticks into converting it up and up and up and up and up and up into something that you can't hear, into electricity that is now being sent out of an antenna through the air. And it can take a lot of power to do that. That's why, size of wires is important. That's why keeping all these things as far apart from each other is important. That's why you use these longer stems to get the antenna. This isn't the antenna. This is the antenna up here. This is literally just coax and some plastic to make it kind of rigid. All this is coax right here. This is all the coax, and then this is plastic around the antenna elements that are up here that make it circularly polarized. All right, so I guess I'll wrap this up. That's my vlog for today. First one ever. Maybe you guys like this, maybe you don't. It definitely helps me organize my thoughts, I think, more about why I do things, what I'm doing. And, you know, one last thing, when you land, you want some really high visibility tape so that you can see it better. These things just disappear easily when you're out in a big field. It's hard to see them. So I buy this reflective tape from Walmart, and it sticks really well. Put it on here, and it comes in different colors, but the yellow is very high visibility, and it's just some high visibility tape that's for like construction hard hats and things like that. So that's what I use. Hopefully this sounds good to you guys. If you did like it, actually like it, push that little like button and subscribe and put a comment and say if you learned something. Sometimes there's people out there that go, "You're a bloomin' idiot." Put that out there if you want. I don't care. I mean, hey, you know, if you watched it and that's your opinion, yeah, I'm happy to hear your opinion. Put it in there in a comment. And that's all for today. Thanks.